from DBMS that has came in GATE 2023. Let us first read the question properly. What is the question that is saying that consider the following table named student in a relational database. Okay, so this is the table that has been given and the name of the table is student. Now it has been mentioned that the primary key of this table is roll number. The roll number is the primary key. The SQL query below is executed on this database. So on this table, this query has been executed. Let us read the query. Select star from student where gender equal to female and mass greater than 65. What it is saying that? It is saying that select all those rows in which the student gender is female, F means female, and the marks of the student is greater than 65. And that is the question. The number of rows written by the query is. So it is asking that how many rows will satisfy this condition. So the first condition is gender should be female. Let us see how many rows are satisfying this condition. This row, and this row. There are 3 rows which are satisfying the condition that the gender is female. But we have one more condition. What is the condition? Is that the marks should be greater than 65. So marks greater than 65. So this is the marks greater than 65. This is the marks greater than 65. But not this one because this is the marks equal to 65. So it will return 2 rows. First row is 2. The roll number is 2. The name is Alia. The gender is female and the marks is 70. And the other row that it will return is 3. Alia. Gender is female and marks is 80. So these are the 2 rows that will be returned by this query. So the answer will be 2. Okay. So now this is the next question that has came in the GATE 2023 from DBMS. So what happens now whenever we see a big question, the student sometimes fear that they will not be able to solve. But always remember, whenever you see a big question, lot of diagrams and lot of content that is written here, always you will see that the solution is very easy. Okay, so let us try to read the question properly and then solve it. So what has been mentioned in the question? Consider a database of fixed length records. Okay, the record of fixed length, not variable length, is stored as an ordered file. The database has 25,000 records with each record being 100 bytes. So how many records are there totally in the database? Total number of records are 25,000. Okay. Always underline the important things that have been given in the question. With each record being 100 bytes. The size of each record is 100 bytes, of which the primary key occupies 15 bytes. Okay. Whenever we do the indexing now, what we use key value. So that key occupies the 15 bytes. The data file is block aligned in that each data record is fully contained within a block. The database is indexed by a primary index file, which is also stored as a block aligned order file. The figure below depicts this indexing scheme. Here you can see how the indexing is done. Here in all these blocks, the data is stored, right? In which the primary key is of 15 bytes and the other fields are of 85 bytes. But all these blocks are storing the data. And then on all these blocks, the indexing is done. Okay. Now, suppose the block size of the file system is 1024 bytes. This is the block size. And the pointer to a block occupies 5 bytes. So whenever we do a indexing, the index block, what does it contains? It contains the key value and the pointer to that block, right? So the block occupies 5 bytes. Now it is saying that the system uses binary search on the index file to search for a record with a given key. It means there will be a many number of index blocks, and all these index blocks, the binary search will be performed, and when a particular key will be found, Then on that directly on that key we will go to the data block. So there will be lot of index blocks, and on all those index blocks the binary search will be performed. Now it has been mentioned that you may assume that a binary search on an index file of B blocks. It has been mentioning that suppose there are total number of B blocks, B number of index blocks. So whenever you will perform binary search, it will take how much time? Log of B base 2 block accesses in the worst case. Now it is asking that given a key, the number of block accesses required to identify the block in the data file that may contain a record with the key. In the worst case, it is saying that suppose you have been given some key, then how many block accesses will be required to access that data block with that particular key. So now you can see here it has been mentioned that we have to do the indexing, right? So we should know how many index blocks are there. When we will know how many index blocks are there, then only we can perform the binary search, and then we will know the number of block access required will be log of B base 2. Okay. So let us start. So first thing you can see that what is the block size? The block size is given as 1024 bytes. Let us write block size is equal to 1024 bytes. Okay, this is the block size. Now what is the record size? You can see each record is of 100 bytes. So let us write record size is equal to 100 bytes. Now you can see the block size is of 1024 bytes and record size is of 100 bytes. So in one block, how many records will come? So let us calculate the block factor. Block factor means in one block, how many records will come? So block factor equal to block size divided by record size. Now what is the block size? Block size is 1024. What is the record size? It is 100. So it will come out to be 10 point something, and we have to take the floor value. So it will be the block factor is 10. It means in a block 10 records can come. Okay. Now in one block total 10 records can come. So if you see how many records total are there, 25,000 records, right? In one block 10 records can come. It means how many blocks will be required for data? Number of blocks for storing data. How many blocks will be required? In one block 10 records can come, right? And how many total records are there? 25,000 divided by 10. So how many blocks will be required? Total 2500 blocks will be required, right? Now we know that in this level, the way that we are talking about the data, how many blocks are there in the data part? Total 2500 blocks are there, and on these blocks we have to done the indexing, right? So now we have to see whenever we will take an index block, what will the block factor of the index block? Here we have done the block factor of, because in the data block we have the data, but in the index block what do we have? We have key and pointer, right? So let us calculate the block factor for index blocks. Block factor for index block. Now we can see what is the size of a block. It is 1024. The size of a block is 1024, and in the index block what we will have? We will have two things. One is the key and the other is the pointer. What is the key size? Key size is 15 bytes and the pointer size is 5 bytes. So in each record of index block, the each record size in index block is 20 bytes, 15 plus 5. So in each index block, how many records can come? If you can see, it will be 49. It will be, if you can just see, 1024 divided by 20. It will come as 51, means in an index block total 51 records will come. Like this is the, this, suppose this is a one block, so this is one record, this is the another record, so total like this, total will be 51 records in an index block. So how many index blocks we will require? Now because each pointer will point to a block, right? Each pointer will point to a block. So one index block will totally point to 51 blocks. But we have total 2500 blocks. So how many index blocks will be required? Number of index blocks equal to, total blocks are 2500 and each block can point to 51 blocks. Divide by 51 and it will come out to be 49. So total number of index blocks are 49. Now if you see here it has been mentioned that this is B. This B was the number of index blocks. So now we have calculated the number of index blocks are total 49, and it has been mentioned that the time taken to access is log of B base 2. So now number of accesses required, number of accesses required equals to log of 49 base 2. So it will be, now you have to take the CL value. Here you can see 2 to the power 5 is 32 and 2 to the power 6 is 64. So this log of 49 base 2 will be something 5 point something, and you have to take the CL value. So it will come out to be 6. So how many accesses will be required? Total 6 accesses will be required. So the answer will be 6. Okay. So I hope this is clear to all of you now.